Yes, you can create PDFs. All right, so as I said, Gnuplot supports many different output formats, and it refers to these as terminals. So there's a terminal to plot to the screen. There's actually multiple terminals to plot to the screen. The one that we've been using is the X11 terminal. And then there's several terminals to plot to image files, PNG, JPEG, PostScript, PDF, Tyler. And what's actually nice about this is that you can have your a version of Gnuplot installed that doesn't support all of the terminals. Basically, they've got kind of a plug-in system where you can add new terminals to Gnuplot so that you can automatically support like a new output format. So the only ones that we really care about are going to be PNG and JPEG. PostScript is one that you might run into if you start building LaTeX documents. X11 is the one that creates a graph on the window, and there's also one that will create a graph in the terminal. That's called dumb. Let's just see what that one looks like for fun, for kicks and giggles. So if I do Gnuplot, set term dumb, plot sign of X, I get an ASCII plot, which we'll do in a pinch if you absolutely. So that's the dumb terminal.
Beautiful.
It is, isn't it? All right, so let's look at creating images. So I'm going into the sandbox directory for today. 227. And then I'm going to go into the data directory, and we've plotted this file in the data directory before. It's the oscillation.txt file. So I've got, looks like I've already got my PNG in there, oscillation.txt. So you guys aren't going to have these PNGs in here yet, or the PNG or the JPEG yet. All right, so to create that, I'm going to start up Gnuplot, and basically I plot just exactly the same as I normally would. All right, so I'm going to plot this file, and this is the X11 terminal. And it's usually a pretty good idea to just plot it to the screen first to get it the way that you want it. And then we're going to change the terminal and replot, and it'll create a picture of it. So the way that you change the terminal is you set the terminal option, and term is shorthand for terminal. So set term PNG. So I'm saying set the terminal to the PNG output. And you're going to see something that kind of tells you information about the settings. So it says terminal type set to PNG. Options are no crop, enhanced, size. You know, it's got 640 by 480. So if you wanted to make bigger pictures, for example, you could figure out what the options to change the picture size are if that stuff matters to you. So you have some control over what's going to happen when it outputs this. Now, you have to set the terminal so that it outputs PNG. If you don't set the terminal first, right, it will output X11 commands. It's going to output PNG commands. And let's see what happens if I just try to replot now.
Yeah.
I get a screen full of just junk. Well, this is PNG format. If you open up a PNG file, it's going to look kind of like this. So that's what's going on. So there's two things that you have to do. You have to set the terminal so that it'll output PNG code, but then you have to tell it to output that PNG code to a file. And you do that with the output option. So I need to set output to the name of the file I want to create. So the two things are set terminal PNG, set output. And again, this extension is not enforced. It will not put an automatic extension on there for you. So you should name this .png because a lot of other people are going to expect PNG images to be suffixed with PNG. So I'm going to create a file that says that is named .png. So I set that output. Again, nothing happens until you replot it. So now I need to replot the plot, and now I've created a file. Now, there used to be a bug that I never took the time to really figure out exactly what the details were, but basically what happened was if I didn't set my terminal back to X11 before I closed Gnuplot, it wouldn't write the PNG file. So I have a habit of setting my terminal back to X11 before I close so that I know that PNG file is going to be created. And now if I plot something else, right, it actually goes to the screen. So if you want to create a file and then you want to go back to plotting stuff on the screen, you just set your terminal back to X11. And so here you can see that it says closing oscillation.png. So I think the problem, and maybe it's fixed, this is just a habit that I've gotten into several years ago. The problem was that it wouldn't close this oscillation.png before I exited Gnuplot, and then I'd be left with an empty PNG file. All right, so let's look at what that file looks like. So let's exit. I've already got that file before, but I just created a new version of it. So you should see oscillation.png in your directory now. It's going to write the file to the working directory, which is the directory that you opened Gnuplot in. Now, how would I go about looking at that file? Well, Derek would open up the file browser and then browse to this directory and then double click on it. But let's just try to open that file directly and see what happens.
Oh,
Yep, he's already got that file browser open.
man.
You're only hurting yourself, Derek, so you just do whatever it is you need to do. All right, there's a program called Eye of Gnome. EOG is the shorthand for that, and it opens up picture files. Now, the problem is it may not be installed by default. So if you get the program Eye of Gnome is currently not installed, please ask your administrator to install it. Then you just need to install it, which for all of us just means run sudo apt install EOG. All of us meaning not Dorn. For Dorn, it means log into an administrator shell and then run this. Did you get that fixed? Of course not. It hasn't come up since then. Do you remember how we logged into an administrator shell? SU tac. So it's SU space tac. Then you give your root password. Remember, and that one was like the password 1, 2, 3. And then you can do this. So you need to install the Eye of Gnome program. Type in my password here.
It takes a little while. Unpacking.
It's downloading, unpacking EOG. 3.14.1. It's interesting.
What's the difference between APT install and APT-K install?
I don't know. It used to be that APT wouldn't, that there was a whole set of subcommands like apt-get, apt-query, apt-search. And I think that they've since then written like a single, like the apt command, which basically just calls those for you. So it's a single command. You used to not be able to search, like you can't search for packages with apt-get, but you can with just apt. Alrighty. So now EOG should be installed. EOG oscillation.png, and I get a picture of it. And you'll see, here's the font. That font's probably different than what it looked like, excuse me, in X11.
Why does it say couldn't load icon error writing?
This is just, this is the nice thing about running it from the terminal. You get to see all the warning messages that they just print to screen. So here it is. Couldn't load icon, error writing. So there it is. That now you can take and you can put into like a Word document if you wanted. Open up Word, go into Insert, click on the Images button, insert that in. What'd be really nice is that if we had a Gnuplot script that ran and generated this PNG, and then we had another script that ran and automatically updated our report with the new image, right? Which we can't do unless we're going to use LaTeX, which of course we are going to do later on in the semester. Right? So we're looking to try to automate our tool chain here. So if you want to create a Gnuplot script to generate that PNG, all you have to do is write a script with those commands. You got to set the terminal to PNG, set the output to the name of the file you want to create. If you wrote a Gnuplot script, then you could just replace this oscillation.txt file with updated data. So let's say you are doing something, you generate a plot, it's not right. All you have to do is replace the data file, rerun the script, it's going to automatically update. So I think Jack has his typical requirement is that he'll give you a Gnuplot script. You're supposed to edit a data file, put your data in there, and then you rerun the script and it automatically generates the graph for you, right? Because he's created a Gnuplot script that generates these pictures. Let's look at another one. Go ahead.
So you showed that we need to close the file that we're accessing so that it will actually generate the PNG.
Mhm.
How do we go about doing that without generating a separate graph?
What do you mean without generating a separate graph?
Because you achieved it just by generating a new sign of X
Hmm.
graph.
If I set terminal to X11 and then exit, it'll do that.
Okay.
I don't have to plot again to do that. I just set the terminal back to X11, and then when I close Gnuplot, it'll close it correctly. And you may be able to do it without doing that, right? This is just an issue that I ran into a long time ago. All right, I'm going to plot sine. First thing I'm going to do is I'm going to set the X range to be 0 to 2 pi. So that's a full period of sine. One thing that you'll notice right here is that pi is a variable that's already defined in Gnuplot, so you can just use it for setting things like the X range. So this is from 0 to 2 times pi. I'm going to set the Y range so that it's not, so that the sine wave doesn't touch the top and the bottom of the graph. So I'm going to set it from -1.5 to 1.5. And I'm going to go ahead and set my X labels and Y labels. So the Y label is going to be displacement and the X label is going to be time. I can do all of these settings before I actually plot anything, right? And then the plot is going to have these settings on it. All right, so let me plot sine of X and I'm going to remove the key. All right, so there it is, from 0 to 2 pi, one complete oscillation. That's the nice thing about pi being defined, is you don't have to try to figure out, where to put that right-hand side exactly, right? It's 2 times pi, so it's like 3.28 something, but you can just use pi to calculate it. All right, so now I'm going to set the terminal to JPEG. Now, there are many different extensions that are used to mean JPEG, and they may actually have different slight meanings. The most common extension is just JPG, but the terminal name here is JPEG. Okay, so I'm going to use the JPEG terminal. Again, it has some options that I could set. So it looks like I could set whether or not it should be cropped. That's probably gonna determine whether or not there's a little bit of a white border around the plot inside the image, or if it's going to be cropped to just make the smallest picture it can that still includes the plot. It's got a size and a font option, so you can change the fonts too if you wanted to. And then I'm going to set the output to sine.jpg without the E. And then I got to replot it in order to get it to actually write to that terminal with the output set to that file. So I replot that. And then I set my term back to X11 and I exit. And now I've got a JPEG in there, which I've had this whole time. And let's see what that looks like. There we go. Which one you use is purely preference. Both of them are well supported. I typically use PNG because they're easy to get embedded into a web page. So when I make my slides, upload a PNG file into the slides, it always shows up correctly. Is everybody able to do this? Donor?
I did not successfully get the EOG thing installed, so.
Have you been able to create those? What's the name of the program that you're using, Derek? When you just double click it and open it up. Do you know what it's called?
Oh, it opened up the same thing. I checked.
It's I've known.
But I didn't open it until after we had already downloaded the EOG, so I don't know what it opened with before that.
All right, so let's get I've known installed for you.
I think I put something in.
So just delete all the stuff except for SU dash. Okay, hit enter. We should ask you for a password. So this is the admin password. Okay, so now do apt install EOG. 2 L's.
That would probably be right.
Yep. Yes, he wants to install. It's actually not even asking.
I was missing it now.
That's why you let the computer spell for you.
Let's try tab. Actually, I don't know if we'll tab. Put it install. All right, there you go.
Oh, yeah.
Now you can exit.
That one you do have to spell.
Change your step size?
Is it working?
Yes.
Step size for what?
Like your X.
What do you mean by step size?
So like it's going through and like to generate the points, it has to generate a list of like.
Oh, yeah. The samples option does that. So I think by default it does 100 samples. If you find that your function oscillates too fast and it's jagged, then you can increase the sample size. Actually, this is one that would be very common. So let's do that. Let me open up Gnuplot, and I'm going to plot sine of x with a high frequency. That didn't look like sine of x at all. What is it? Oh, I'm plotting just 30 times x. There we go. That's not. God, that would be great.
Wow, that's a little jagged.
Just all I'd have to do is show up during class and not think about this at all outside of class. Like do no prep work outside of class. That would be great. All right, so here is sine of 300x, which is we actually see some aliasing and beat effect going on. So this thing is sampling every, like I said, I think by default it's 100. So it's sampling every so many x points, and you can see where those are. There's one right here. Here you can kind of see, actually, let me blow it up. So here you can see where the two consecutive points are. Here it's actually skipping the peak. And so this sampling rate is just out of sync with the frequency of the sine wave. And so you see it reaches the peak up here and then it comes down and reaches the peak up here. This is basically aliasing. You got this is aliasing, and it's basically a beat effect. So you have a frequency for your sampling and you have a frequency for your signal. And if those aren't the exact same frequency, then you get this second oscillation that appears to occur, and that's proportional to the difference in the two frequencies. But I digress. So let's make this higher resolution. Set samples 1,000. Replot. There we go. Now it looks a little bit better. You can see that it's still a little bit, no, actually that's kind of smooth. That's kind of smooth. It looks like this one right here is getting capped off. Now you can't tell if it's getting capped off because if you zoom in on it, it just resamples over the zoomed in range.
Yeah, don't set it too high.
If you set it too high, it's going to take forever. So I'm sure that the first thing that Derek tried was, I wonder how many of these I can put in here.
No. I put it to 100,000.
100,000. Let's see.
Put it to
Integer.
100,000.
Oh wow! Look, this is even warning me that there's an integer overflow if I try to use a number that big.
Yeah, just set it to.
So if I do that, now I can see the Gnuplot is cranking away
It's gonna come out as a solid bar.
because it's got to plot, it has to generate all these points and then it has to calculate sine at every one of those points, and it's taking some time.
Yeah.
I set my X range to like 3,000.
Yep.
And just have my samples at 10,000, and so now I get an almost entirely purple screen.
Yes.
Yeah. I would have keep reopening itself.
All right. So that's how we create images. Is everybody able to create and view their image?
Yes.
All right. So don't forget the two things. Set the terminal and set the output. If you forget to set the output, you're going to get a screen full of garbage. All right, next thing that I want to discuss is variables. We already saw variables with shell scripts. In shell scripts, it was a little bit strange because you'd set the variable, and then when you wanted the value of the variable, you had to put a $ in front of it. That is not very common for regular programming languages. In Gnuplot, you do not have to use a $sign to get the value of a variable. So variables are very simple to use. You just pick a symbol. It doesn't even have to be a single letter. You can pick a name that you want to use. So I'm setting m equal to 2 here. Print is a nice command to just print out the value of variables or functions. Like you could evaluate a function at a given position and then just print that value. So if I just print this variable m, I see that it's 2, and then I can use that variable in plots. So if I plot m times x, that's the same thing as plotting 2 times x. Now, you know, the more complicated your expressions get, the more useful variables are going to be. But really, we have to understand how variables work if we want to do function fitting, because they're going to use variables when they do the fit. So let's look at how variables work. There's a couple of, not necessarily gotchas, but little caveats where you have to realize, you know, you can see where if you have 2 variables that are named the same thing, which one is actually going to be used. All right, so I'm going to go back to my sandbox directory, which I start over every time. I'm going to open up Gnuplot. So I'm in the top directory now, but I'm just going to plot some functions, so it's not going to matter. Okay, so let's plot 10x plus 2. Straight line, y-intercept is 2. It's going to have a slope of 10. Now let's just use a variable instead of explicitly typing in 10 times x plus 2. So let me set m equal to 10 and then plot, well, let me set b equal to 2 and then plot this as the equation for a line. So I'm going to use a variable named m and a variable named b, bless you. I've got 10 and 2 for those variables. And I'm going to plot mx plus b. Gives me the same thing. What's nice is if m showed up multiple times in this thing, or if I had multiple functions that I was plotting that all involved m, then I could change the value of m and then quickly update the plot without having to go through and change each instance. So now I'm going to set m equal to 5. I should see over here the slope of this line change. It should be half what it is currently. All I have to do is replot, and it's not like the plot command is going to take the value of m that it was used to create and generate the plot. It's going to use the expression that was used to create the plot. So m should be updated here, and I see that, yes, the y range changes when I change the value of m and then replot. Now, we talked about functions last time. Functions can also use variables. So this is just defining a function that is a function of x, and I'm just setting that function equal to the equation for a line. So m times x plus b. When I do this, the variable m and b are going to have to be defined before I plot this, right? So if I plot f of x, I get the same thing because it's basically just another way of writing the equation for a line. M and b are both set. M is 5, b is 2. So plotting that function works. If I set the value of m to 10 and replot the function, I'm going to get the same thing. Well, I'm going to get a different slope, but it's going to work. It's going to update with the value of the variable. So the function can refer to variables that are defined outside of the function. Here's an example of something that wouldn't work. So let's do double f of x is equal to a times x plus b. All right, so I can define that function fine. But if I try to plot double f of x, it says undefined variable a. All right, well, let's set a equal to 2 and try to replot. Is b defined? Undefined variable, so plot. Oh, I tried to replot to redo that error, but the replot command is only going to replot the last successful plot command, so it didn't actually try to redo the plot command that failed. So now I'm going to plot double f of x, says undefined variable b. I set that variable, then it works. So you can define the variables outside of the function. The other thing that you can do is you can define a function that takes multiple arguments. So here I've got a function g that is going to take an argument m, b, and x. And then I'm going to set that equal to mx plus b. It's the same thing as before, except now the function takes arguments that are labeled m and b. So which one's going to get used? Well, the arguments are going to get used. So if I try to use this function, if I plot this function, the value that I set the variables m and b to are going to be ignored by this function, right? The values for the first and second argument are going to be the things that actually get used by this function. Exactly. So there's scoping that's going on in here. So if I try to plot g of x, I'm going to get a complaint that g of x requires 3 variables, right? That it requires 3 arguments in order to plot. So to plot something using this function g of x, what I have to do is I have to give it values for m and b. So this is going to plot a line that has a y-intercept of 2 and a slope of 10. I still have to use x to tell it what I want it to use for the independent variable. This is nice to do because then, like if you've got a function, this is an easy function to look at, but let's say you've got a function that has a couple of parameters that it depends on. You can plot the function with different values for the parameters to see how this function depends on those parameters. So in this case, I'm going to plot the function with a slope of 10, y-intercept of 2. Then I'm going to use a slope of 5, and then I'm going to use a y-intercept of 1, and I'll see how that changes the function. So I've got a slope of 10, a slope of 5, and a slope of 2, and then the y-intercept here is also different. So I can see that the slope changes how steep the line is here. Let me zoom in and see if yep, they don't cross at the same point because I've got the y-intercept for this last one changed. If I wanted to use the variables m and b, this is where it can get a little bit confusing. So in the function definition, I've got m and b, but those are not the variables that I define m and b. If I want to use those, I can just pass those as arguments to the function. So this is going to use the value for m and the value for b in the functions version of the value of m and the value of b to create a plot. Now, what's really nice about defining functions of multiple arguments is there's nothing that says so up here, where did I put g? G is right here, right? There's nothing that says just because I used x for this argument name that I actually have to plot this function as a function of just that variable. I can change which one the plot command is going to insert values for by just giving x to a different argument. So in this case, I'm going to plot g of x, comma 2, comma 2. That's going to plot this function is a function of the slope instead of a function of what we would normally call x. And I could insert g or I could insert x into the second argument. So this would be plotting the function, changing the y-intercept. So how would I interpret what this line is? Well, what this line is telling me is that if I had a function that was 10x plus b, and I looked at the function at x equals 5, and then plotted a bunch of those on top of each other, this is what the y-intercept of those, or this is what the value of that function would be as I change the y-intercept. So if I have the y-intercept set to 5, the value of that function is going to be around 50. So a combination of variables and functions can be very useful at times. So here's an example of maybe one where we actually we don't know immediately how the parameters in that function affect what the function looks like. This is just an exponential. So I'm going to create a function. It's a function of capital A, little a, and x, and this is just going to be an exponential. So this is a times e to the negative ax. So I define that function, and then I can plot that function. So this is going to be a is equal to 1 and little a is equal to 1, and I get this exponential decay. Now, the thing I notice is that we've already seen this goes to something really big as I get to the left. Basically, no matter how far to the left I go, it's just going to keep getting bigger and bigger. Let's just look at this on the positive real axis. So on the positive real axis, if I plug in x is equal to 0, I should get a. So this should be whatever the value of a is at x equals 0, and then I'll get an exponential decay. So I'm going to set the x range from 0 to 5, just so I can see what this function looks like. So I plot 1, 1, x, and I see that on the left-hand side now, the value of the function is 1. So here's just straight exponential decay. Now, this variable in the definition of my function, I've got exponent of negative ax. That parameter a determines how fast the function is going to decay, like how fast it goes down. You make that bigger, it goes down faster. You make it smaller, it goes down slower. And we can see exactly how that parameter changes the function by just plotting this function with a couple of different values for a. So I'm going to plot this function 3 different ways. All of them have an amplitude of 1, but then I'm going to change that decay rate. I'm going to set it to 1, I'm going to set it to 2, and I'm going to set it to 1/2. And I get these 3 different exponential decays. The first one, the purple one, is 1. The second one is green. So if I make a in the exponent bigger, I get a decay that happens faster. And then the blue one is the 1/2. So if I make that a in the exponent smaller, I get a slower decay. This one's for Jack, just in case he's watching. I'm going to leave off that leading 0 for 0.5. See if Gnuplot complains. It does not. Only Jack complains about that. Now I'm going to plot a function with the same decay rate, but I'm going to change that amplitude part. So I should basically see them all, right? I've got 2, 1, and 1/2. They're all decaying. They have the same decay rate. It looks like they're decaying at different rates, but really, I mean, yeah, one of them goes to 0 faster. But if you looked at the ratio of, like, if I looked at this green one and I took the ratio of its value at 0 and its value at 2, that ratio would be the same for the blue, purple, and green. Now I'm going to use a variable. So remember, we used capital A to define these functions. Capital A is not, I mean, inside the function is going to use the argument for its, when it generates this plot. So if I set a variable capital A that I actually want this function to use, I have to pass that in as an argument. So I get the function where I've got amplitude is equal to 1 and decay rate is equal to 1. And then this one, I have to pass in this variable explicitly to get it to use the value 2 for that. All right. So variables are very useful, and they're going to be especially useful, well, at least need to know how they work or what they are in order to do the next piece, which is function fitting. So one of the most powerful features of Gnuplot is function fitting. Gnuplot's so good at function fitting that sometimes you'll use it just to do a fit. Like, you don't even really need a plot of your data. All you want is to do a fit of your data and get the parameters that fit your data, and you'll use Gnuplot to do that. And the nice thing is, which is probably beyond the scope of what we're going to do, but the nice thing is that Gnuplot 5 now has the ability to not only fit a function to data, but to account for the error bars. So if you've got uncertainty in the x direction and uncertainty in the y direction, Gnuplot can account for that when it does the fit. So if you've got a data point that's got very small uncertainty and you have another data point that has very large uncertainty, well, the one with small uncertainty should count more when you do the fit, and Gnuplot's algorithm accounts for that. And you can do uncertainty in both the x direction and the y direction. And if you're interested in that in more detail, Jack is the one that's got all that figured out. Jack uses Gnuplot for all of the advanced lab stuff. And when they need to do function fitting, this is what they use. So there's a command called fit, and the fit command takes a couple of things. One, it takes the function that you want to fit. And this can either be a function that you've defined, or it can be just an expression that you write out. It takes the data file that contains the data you want to fit to. And then it takes a list of the things, the parameters that you want Gnuplot to adjust to try to get the fit to work. So in general, it might look like this. Fit mx plus b, so this would be fitting it to a line, name of the data file that contains the data, and then you got to put this via word here, and then you give it a list of the things that you want it to change to try to get the fit to work. So this is going to be the equation for a line, and I'm telling it to adjust both the slope and y-intercept when it does that fit. I can tell it to only adjust the slope or only adjust the y-intercept if I want. Note, I don't have any examples of this, but this file name that you give, like let's say the data you want to fit is actually in the first and fourth columns, you can give the same options that you give to the plot command here. So you can say using 1:4 and then do the fit on the first and the fourth columns.
Would that be after?
It would be after this text file. All right. In the sandbox directory, I have a directory called fitting. It's quite a fitting name for such an activity. So I'm going to open up Gnuplot in the fitting directory so that I have this data file available. And let's just see what we have. Okay, I got a plot. I've got a data file named example.txt. I'm going to plot that, see what it looks like. This is what it looks like. You can see that it looks like pretty much a line. There's a little bit of, it's not a straight line. I can see for sure this one dips below, but it's basically a line. So perhaps I did an experiment in Phys 1 or Phys 2 lab where the data I collected I expect to fall on a line. And now what I want to do is determine the equation for that line that fits this data best. Best fit line. What's really nice is, Excel can do best fit line. Excel can do best fit. There's a couple of functions that it can do, but with Gnuplot, you can do best fit arbitrary curve. I mean, you can just define the function that you want it to fit, and it will try to do the fit. Now, sometimes it's harder to get it to fit than other times, but you can create whatever the function is that you want it to fit. All right, so the first thing I'm going to do is I'm going to adjust the X range here so that, and it doesn't look like it's too bad on my graph right now. Sometimes the first and last data points are on the axes. So I'm going to adjust the X range to get the data points in the middle. So here I've got my left point, my right point. Those are definitely in the middle of my graph. And then I'm going to set the Y range to do the same. So I'm going to set the Y range so that it's not quite, this might actually not be good. Let's see, I might be missing one of those. I think I am. So let me set the Y range from 2 to 16. There we go. Now, one thing that's especially for trends like this trend goes from the bottom left to the upper right. And this point right here sometimes gets confused for a data point. Is that a data point right there by the key? No, it's not. That's just the key drawing a picture of the symbols that corresponds to this data file. So let's say that I don't like that, and I want to make sure nobody confuses that. I can move my key to the left by setting the key option and giving it the left argument. So set key left, that'll move that key over to the left. We already saw that we could turn the key off completely by doing unset key. We can change the various options for the key. We can move it to the bottom if we want. We can move it to the right. So I'm going to set my key to the left, replot. Now that point is not in the way. All right, so what I want to do is I want to fit a line to this to see what the slope and y-intercept of this data should be, what the best fit line looks like. I know that it's a line, so let's just plot a line on there and see what it looks like. I mean, I could plot 3x plus 3, and that's getting close, right? The slope looks a little bit steep. The y-intercept looks pretty high. So I could plot this again and try a slope of 2.5 and then drop the y-intercept down, right? I can basically just do this until I found a line that looked like it went right through the data set. In fact, I think in the old days, you basically draw these points on a graph and then you just kind of look along the side of the graph and then draw a line that looked like it went through all of them, right? That was your best fit line. But what Gnuplot does is it actually has an algorithm built in where it can draw a line, look at the distance of all points to that line, and then try to minimize that distance. So how do I get a line that is the closest possible to all points? It can't go through all points, but you can look at the distance between every point in the line, and you want to minimize that. And that's the algorithm that Gnuplot is using to figure out what M and B are going to be. So let's do it. Let's do the fit. Mx plus B is the equation that I'm going to fit. So I do the fit command. The equation that I want to fit, I have to use variables in this equation. Right? I couldn't do 2x plus 3 because then there would be nothing for Gnuplot to adjust. I have to use variables in this equation so that Gnuplot can adjust those variables to get a best fit. The name of the file, or the file that contains the data that I want to fit, and then this last piece here, right? And it's via, so do this fit via these parameters, and I'm giving it M and B, and I have to separate M and B by commas, or by a comma. If I had more variables, I could tell it to fit 3 or 4 parameters, right? You're going to get fitting is going to be a little more what's the word, fragile if you're trying to fit 4 or 5 parameters, but 2 should be pretty good. And then I'm going to see it spit out a bunch of stuff, and all of this stuff has meaning that I don't know what it means, right? If you look right here, though, you can sort of see, if I look up here, it has some iteration stuff, and then it prints out something here. It says final set of parameters, M equals this, B equals this, and it gives you standard error for both of those. That's the critical piece for JAG, is that it gives you uncertainty in that fit. Programs like, have you guys even had to use Gnuplot? What's that one that's installed on the computers? Yeah, the one that, what is it called?
Gnuplot.
No, not Gnuplot. It's like,
on all these computers.
yes. No, it's the one that nobody uses. Nobody that needs to do serious plotting uses, but it's very simple, and so we have the students use it. It's like Log Pro or Plotter Pro or something like that. The uncertainty that it lists in the parameters that it does the fit on are not the uncertainty in those parameters, right? They're not the real uncertainty in this algorithm. So these are the real uncertainties that you would write down if you did an experiment, you collected this data, and then you were told to extract the slope and y-intercept with uncertainty. Here's the uncertainty that you would use for that slope and y-intercept. This uncertainty gets bigger the worse your fit is. Like if your data is scattered all over the place, that uncertainty gets bigger. Gnuplot quantizes that uncertainty for you. Logger Pro, maybe that's what it's called.
I'm just looking it up.
Yes. All right, so let's say this stuff goes by and you don't get it. You can always, Gnuplot is going to set the value of M and B to these values that it finds for the best fit. Actually, it's constantly changing M and B until it finds the best fit. So you can always get the value of M and B by just printing them out. So these are your best fit parameters right here. These are the values that fit the best. What's really nice is that now I can immediately go and plot the data file and then plot the function mx plus b. M and b have been set to match or have been set to the best fit values. So this is going to plot the best fit line right here. And so I can see, yep, got data point below, data point above, below, above. There's one that looks like it goes almost right through. This is my best fit line.
Yeah, it's Logger Pro and graphical analysis.
Oh, yes. Graphical analysis. Yes.
Yeah, we'll have to use that for all of our graphs.
Yeah. So the error on graphical analysis can't be trusted. I don't know what that uncertainty corresponds to, but it's not the uncertainty in the fit parameters. Not correct. They're not the correct uncertainty, at least. All right. I've got another example in here, example2.txt. And that contains data that is in, well, basically a line as well. If I do, so I'm going to plot this new example file and then the old line, and they are not quite the same. Let me adjust my range again. Set, oh, wait a minute. There we go. So here's the data in the new file. And then here's the line that we just found, right? So it's not the same. And so what I want to do is rerun a fit in order to adjust my best fit parameters so that they pass through that line. In this case, what I'm going to do is, it looks like, well, maybe I know. I mean, maybe just from looking at this, I can't tell. But like if this was supposed to be force as a function of displacement, then I know it should be 0 at x is equal to 0. So maybe I know that I want this fit to be 0 at the origin. Well, in that case, what I would do is, and it looks like I have not. This is gonna keep a constant y-intercept, I think. When I rerun this fit command, I can do fit mx plus b, example 2, via m. If I just say via m, Gnuplot is not going to change the value of b. So if you know one of those parameters in your fit should be something, like you know it's got to be 3 or you know it's got to be 0, you just set the variable to that. And then when you run the fit command, you don't let Gnuplot change that. It's only going to adjust the value of the things that follow via. So this is only going to adjust the slope of this line. It's going to keep the same y-intercept to try to make this fit work. Let's see if that fit actually worked. So I've got 3.9 for my slope and 2.19 for B. So that is the same as it was before. I'm going to plot the data file with the fit, and all it did was adjust the slope up. It looks like if I would have allowed it to adjust B, it probably would have shifted this whole thing down and the slope would have been larger, because it looks like on the left I'm a little high and on the right I'm going a little bit low. And that's just the slope that it had to adjust to get it to fit best, because it wasn't allowed to adjust the y-intercept. Yes, Tyler?
Can't you separate it by a semicolon, so if you want to fit that line and then plot that line, type it all out at once?
Yeah, you could do the fit semicolon, give it the plot command. Yeah, semicolons can be used to give multiple commands on the same command line. And actually, I'm over, so I'm going to shut it down.
Holy, I'm having fun.
Yeah. We can define functions and use those functions for our fitting, which we will see.
I'm just gonna skip. Yep.